Let's jump into the day one topic today, like the overview of DevOps and infrastructure as a code. So today's agenda is we will see what is DevOps and how traditionally the deployment happened and DevOps introduction, Azure DevOps introduction and IaaS introduction and comparison of provisioning tools. Okay. Okay. So any doubt till now? Am I very clear to
Yes,
you?
yes, Suresh. Good.
Yeah.
Yeah, fine.
Thank you so much. Yeah. Thank you. If you feel if I'm going a little bit fast, just just let me know. Okay. Okay. Fine. Okay. First, before jumping into the DevOps or any other IAC, first we need to understand how traditionally they are managing it. Then only we can understand why this evolutions happened, right? So if we see in traditionally, there is one developer who developed the code. Okay, who developed the code for create some product, software product. So usually he will develop the code on his own laptop. Once that is done, he will push the code to the SCM. What is SCM? It is a source code management. Source code management is nothing but it is a centralized place where everyone can store their code. Okay, so that is called SCM, source code management. It is a centralized repository. Let's assume it is a centralized location. Okay, once he commit the code to the centralized repository, he will inform to the operation team. So usually operation team, what they will do, they will just build the code which is on the SCM, okay, and they will move that build file to the share folder. So what is build? See, for example, if you take the Java code, Java is the code, okay. This SCM will have the code, only the coding part, but we have to build it as a jar file, right? So the jar file will be built by the operation team that will be moved to the share folder to install on the different environment. So once it is moved to the share folder, this guy will deploy the product into the different environment, such as test environment, QA, staging, and all. Okay. So once deployment has happened, this operation team will inform to the tester to test the product because the product has been deployed on the specific testing environment. The tester, once the tester is informed, the tester will test the product. Once the testing is completed, he will provide the feedback to the developer. If there is a bug or if there is some changes needed, then he will update to the developer. Then developer fix the code and again he will do the commit to the SCM and again he will inform to the operation team. This cycle will repeat. The operation team again build a new build, move to the share folder. Again, we'll do the new deployment. Again, he will inform the tester. He will test it. Like that, this cycle will be routine until everything the testing is completed. Okay. So once everything is every testing is completed, then finally operation team will will pull the that build file from the share folder, the tested build file, and he will deploy on the production. So these have happened in the traditional way. Okay, okay, this is fine. But what is the problem, right? What is the problem here? That is what we are going to discuss here. First point is communication gap. As you can see, one team has to inform other team, right? And one team has to inform other team. So there is always a communication gap. Okay, that is the first problem. That there is a lot of chances to get the misunderstanding as well. Okay, and second point is manual process. If you see everything is a manual process, he has to push the code, he has to build it manually, he has to move it manually, he has to deploy it manually, like testing manually. Everything is a manual process. So that is obviously taking very no it is a time taking process. Also it leads to some human error. Okay, and it is a long release cycle. As it is a manual process, yes, obviously it is a long release cycle. So for example, if there is some bug, if there is some new feature has to be released, again this entire process has to be taken manually, and it will take the long release cycle. Okay. And inconsistent environment. What is inconsistent environment? For example, if you are doing testing on the testing environment, right? And the same application or the product has to be deployed on the another environment for another kind of testing, the QA or staging, right? Here, the environment should be same. For example, if the server is a Windows server and is specific version, the same version has to be on the QA and staging as well as a prod. Okay. Also in the software product. For example, if you take the Java, so Java version should be same, right? So the operation team has to take care of these things, the hotfix and all. So if there is any mismatch on the environment, the product will work on one environment and it will not work on the another environment. So that is all. So that is the inconsistent environment. Okay. So the operation team has to take care of it. The very important point is lack of automation. As here everything is a manual process, uh, the automation part is missing here, right? So we have to repeatedly, do the same task again and again, and it's sort of time consuming process. So these are the problems we have in the traditional workflow. Okay, so that's why the DevOps concept came into the market. So what is DevOps? DevOps is not kind of specific tools. Just understand that DevOps is a culture. DevOps is a kind of practice. Okay, so it is a kind of practice with set of tools. Okay, to integrate the software development team and then IT team. Okay, so if you split this DevOps, see it is a dev plus op. So development, developer plus operation. So that's called here is a DevOps. Okay, so till now, is there any doubt? Okay, good.
Clear, clear.
Okay, fine. Yeah. So okay, we know why DevOps came into the picture. So DevOps is not a specific tool; it is a set of tools with kind of set of procedure or set of practices. Right? Okay, we have to understand what is that culture or what is the life cycle of DevOps. Right? The first phase is planning phase. First, before develop the product or before releasing any feature of the product, we have to first plan it. Once the planning is completed, the developer has to code it. Once the coding is completed, it has to build it and it has to be tested, and we have to release and deploy, and the operation team has to operate it, and this product has to be monitored. Okay. Till this part is fine. But why it is the infinitive icon? Anyone knows?
Yes,
Why symbol is like infinitive?
Suresh,
Yeah, yeah.
the flow should be frequently released. The version should be the bug would be found out in the application, and then they will keep developing. The plan will be goes, and the development will be like happening in the environment. The test will be happen again. The development flow will be comes.
Exactly. So let's assume, yes, we have delivered the product to the customer. Yes, till this, and we are monitoring it. It is fine. But after that, even though we are testing it, the customer will find out any bug or the customer may need any additional features. In that time, again the same procedure has to be followed. For the new feature, we have to plan it, code it, build it. Again, this structure will be followed. Okay, this is the entire life cycle of the DevOps. Okay. Okay. I now I understood the life cycle of DevOps, but what are the tools available on the DevOps to achieve these phases, right? We'll, we will see it. Okay. The important DevOps practices are, first thing is continuous integration and continuous delivery or continuous deployment. What is continuous integration? Whenever no developer write the code on the laptop, it has to be pushed to one centralized repository or shared repository. Okay, till it has to merge it to the master branch, right? Those called continuous integration. Automatically, it has to be pushed to the repository. That is called continuous integration. And continuous delivery is whenever the new code, whenever the new feature is added to the repository, automatically the build has to be happened, right? That is called continuous delivery. Okay, these things we will be discussed in detail in the upcoming sessions while we are discussing about Azure repository and then Azure pipelines. You will come to know this. Okay, for now, just understand the basic stuff. Okay, and the third part is automation. So automation is a core part of DevOps. If you enter to DevOps, everything will be automated. Okay, that's how we will see how we can automate using Terraform and using Azure pipelines and all. We will see it. Okay, and the fourth thing is infrastructure as a code. So obviously, even though it is a software product, that has to be deployed into any kind of platform, right? It has to be any server, it has to be any of the platforms such as if we take GCP, the Cloud Run or Lambda or Azure Function, whatever it is, right? Or Azure App Engine. So infrastructure as a code is acting as a main part in the DevOps. Okay. Now we will see the DevOps tools. So the first thing is the first phase is plan. We have discussed, right? For planning, we have n number of tools available in the market. So there are few things is Azure Board and Jira and Rally. There are a few other tools are available. Using this tool, we can track the changes or track the activity and we can easily plan it. Okay, so for planning, we can use Azure Board or Jira or Rally and a few other tools are available. And for coding, we can use GitHub repository or Azure repository or code commit. There are various tools available, and Bitbucket, those tools are available. Okay, and for building, we can use Maven, Gradle. These are related to the software, but we no need to worry about this stuff. Okay, just I'm letting you know that. Okay, as we are seeing the DevOps, just have this in mind. Okay, after building it, we have to store it somewhere, right? So for that, we have Nexus and we have Azure Artifact. Those tools are available. For testing, we have Azure Test Plan and we have Selenium. We have other tools are available in the market. And for release and deploy, we have Jenkins or Azure Pipeline or Tekton or GitHub Actions, right? GitLab and Terraform. Those tools are available for release and deploy. And for operate, yes, we can operate using Terraform itself, and we can use Ansible. It's based on the product, okay? And for monitoring, we can use Prometheus, Grafana, Splunk. These tools are available. So what is DevOps? Again, I'm telling, DevOps is not the specific tools. It is a combination of tools. Combining of all tools and having these phases is called DevOps. Okay, so we will see like in this course we will see Azure Board and Azure Repository and Azure Artifact and Azure Pipelines and Terraform. We will see it, but Azure Test Plan we will not see. We will not cover in this course because that is not the field product as well as that is related to the tester. Okay, so but I will give some the basic overview of the Azure Test Plan. Okay, now we know what is DevOps. Now we will jump into what is Azure DevOps. Okay, okay. So anyone can just let me know what is DevOps in general. Just let me know the few tools on DevOps. Anyone?
It's a combination of tools with repositories, GitLab, like monitoring like Grafana, Splunk, and
Exactly.
deploy and release
It is
code like Terraform, etc.
exactly. So it is a combination of tools, right? So if you see, these are all separate tools, right? We have to adopt each tools and we have to ourselves make as a DevOps. But if you go for Azure DevOps, what they have done is they are giving as a suit. Like if you adapt the Azure DevOps service, they the Azure DevOps itself is having Azure repository, board, wikis, pipelines, test plans, artifact. Right? It is a combination. They made it as combination and they are giving as a service. So that is called Azure DevOps. Okay. In the Azure DevOps, there are two hosting options they are giving. Azure is giving two options. One is Azure DevOps Service. One is Azure DevOps Server. What is service? What is server? If you go for Azure DevOps Service, you can in the cloud itself you can access it. If you go to the Azure Azure cloud, here itself you can access as a service. But if you go for Azure server, the server is nothing but in few cases, few of the companies may think I don't want to host my things in the cloud, but I need to have the same kind of Azure DevOps suite, but it should be on my own on premises. In this situation, they can have own server on their environment, and they can install the Azure DevOps suite on that on premises, so that they can have all these component Azure repository, boards, pipeline, everything. The only part is they cannot access through cloud, but they can access using the on-premise component. Are you getting me? Any confusion of service and server?
No, Suresh,
No,
clear.
Suresh. It's clear.
No.
Okay, okay. Let's see the price plans of the yeah. See, this is what I told. Azure DevOps Service and Azure DevOps Server. Okay. If you go for Azure DevOps Service, okay. So here, no, you can have one free hosted, Microsoft hosted, and one self-hosted. I will explain what is Microsoft hosted, what is self-hosted and all when we are discussing about the pipelines and all. Okay, Ju- just see the structure of the cost. Okay, and Azure Artifact you can store maximum 2 GB freely. If you store more than 2 GB, then you will be charged. Okay, for per GB you will be charged a dollar, $2. Okay, so these are the these are the Azure pipeline runs. Okay, how many minutes you can run it, those things. Okay, and if you go for basic plans, these services you can use it. If you go for basic test plans, here where you can have the Azure test plan, you can use it. Okay, that I will explain later when we are discussing about those stuff. Okay, for the basic you can have 5 users free. Okay, okay, and if you go for Azure DevOps Server, here there are two options. One is Visual Studio subscriptions and or Azure DevOps Basic or Plus Test plans. Okay, these are like a monthly subscription plan. But if you go for Azure DevOps Service, that is based on the usage. But if you go for Azure DevOps Server, that is a monthly subscription. Okay, you have to pay it whether you are use it or not. You have to pay it. Okay,
Suresh, I have a query on this.
yeah, please go ahead.
Can you please go back to the Azure DevOps server? With the plan, I could see that the first option for the Visual Studio subscription. Uh, for example, I have a 10 subscription with us. In the sense, the application is free. I thought like that, but even I could understand that the server also is free. So the $45 per month, how the charges will be work?
How the charges will be work?
Yes.
Okay, let me see that.
So I'm already paying for Visual Studio, but for 10 users. You're saying that entirely the server is free? The Azure DevOps server is free, the
No, no,
on-prem
no.
base. So
The server is not free. See, the server is your own server. Okay, you have to deploy your server. Only the
hmm.
product will be installed on your server on your on-premise. Okay, there for using their product, you have to pay this much of cost. Okay, but but on what basis this right? That I need to check that. Mm,
Fine,
Okay,
understood.
okay, yeah.
Thank you.
Yeah. Okay. Now we know what is DevOps, what is Azure DevOps, and now we will jump into how to create account on the Azure DevOps, right? So first of all, you need to have Azure account. Okay, you need to have Azure account. Just log into Azure account. If you search for Azure DevOps, just click this DevOps organization. Okay, here, if you click here, it will take you through the specific window. Okay, let me tell you. Wait. Okay, already I'm having the organization. If you don't have organization, you can create a new organization here so that you will have a new link for your Azure DevOps repository. Okay, I mean Azure DevOps. So let me go to this specific organization. So this is my organization. For example, dev.azure.com. That is the Azure DevOps portal. In that, after that, whatever comes, right, that is my organization. Okay. And if you go for the normal Azure portal, that is portal.azure.com. This is separate. This is completely different thing. This is completely Azure cloud. But if you go for Azure DevOps, that is dev.azure.com. Okay. So I will provide these links in the GitHub repository. Just click this link. There you can have option to create the organization. Just click the create button. You will have the organization name. Okay. After that, you can access your DevOps, Azure DevOps using this specific link. Okay. dev.azure.com/your organization name. Okay. Now let me show you. Okay, now I logged into the Azure DevOps portal. Okay, this is my organization. Okay, once I log into organization, these are my project. Already I have created it, but later we will see it in detail. Let me show you just a few things. See, these are things. This is the suite actually. See, they have given wiki and Azure board, Azure repository, Azure pipeline, and Azure plan and the artifact. So these tools they have included combinedly and they have given to us, and we can access these as a single service. That is called Azure DevOps. If you don't use Azure DevOps, you have to adopt each and every tool separately, and you have to make yourself as a DevOps culture. Okay, fine. Any doubts on the Azure DevOps now? We will move on to the infrastructure now. Good. Okay, fine. Okay. Now we need to understand what is infrastructure. What is infrastructure? It is just a combination of component to operate something, right? Such as computer, network, storage. These are the infrastructure in the IT segment, right? So how traditionally they manage the infrastructure? So let's say, there is one admin. He want to create some set of servers on the development environment. So he's taking 5 days. Okay. The same set of component set of infrastructure has to be created on the QA and staging. For that also is taking 5 days traditionally, right? Because everything is manual process here. So he has to document how he created on the configuration, everything he has to document, and he has to submit to the admin too, because the one person cannot do all this stuff, right? So he have to share the work. So he has submitted a document to the admin too. He is doing the same thing on the staging, production, disaster recovery for all the environment. So if you see, to complete all this environment is taking almost 25 days to complete this work. Also, one more problem is if you miss something on the documentation, then that will lead some delays or some outages, and it is a non-sync environment, right? That is the problem. And one more thing is, suppose if you want to add the extra infrastructure, it is a time-taking process. You have to add more no uh, what is that? You have to include more workload, right? So these are the problems in the traditional way. Okay, okay. Just keep that part along. We will discuss how it can be rectified. Okay. So before jumping into that, we will see how Infrastructure is handled the DevOps culture in traditionally. The same thing. Like there will be a developer, he developed an application, okay, that has to be deployed into any kind of servers, right? Any kind of infrastructure, right? So for that, the operation team has to set up servers, configuring network, route tables, installing the required software, everything he has to done that, right? So after that, he has to maintain it, and he has to follow the same thing on the different environment, right? So what are the problems on these? So there is a high human cost involved, and there is a time consuming process, and there is chance for human error, right? Okay, these are the problems in the traditional way to create the infrastructure actually. Okay, okay. To avoid this kind of structure, these kind of problems, we came into the concept called infrastructure as a code. Okay, what is infrastructure as a code? You are doing something manually. You are, for example, let's say you are creating the VM manually. Okay, instead of creating manually, if you create that specific resource through the code, then it is called infrastructure as a code. Just to read this out. Managing and provisioning of infrastructure through code instead of through manual process, that is called infrastructure as a code. Got it? So what is IAC? If you want to do something, if you want to create, if you want to manage something, some infrastructure, if you do this through code, that is called infrastructure as a code. Okay, see this example. This is the example infrastructure as a code. This is a sample Terraform code. This is a sample Ansible code. Just if you see it, just here we are mentioning what is the AML should be used, and what should be the instance type, right? And here the same thing, the Ansible code. It's a very simple code. It's like a key value pair, right? So this is called infrastructure as a code. Okay, we will discuss in detail when we enter into the coding part. Okay, what each and every line we will discuss. Okay, I will make you understand. So usually the infrastructure code, right? The infrastructure as a code, the code itself is acting as infrastructure now. So those will be stored on the repository. It may be Azure repository, it may be GitHub, it may be Bitbucket, whatever it is. We will store it on the repository. Okay, and using that repository, we will create this. Using the IAC tools, we will create the network, security, infrastructure, storage, the other so many things, right? So the flow is we have to store our code in the repository and using IAC tools. What is IAC tools? Here we are saying Terraform. So using Terraform, we can create this infrastructure. Okay. Okay. Any doubt till now? Good. Okay. Okay, we have many IAC tools available in the market actually. It's a Terraform and a Google Deployment Manager, AWS CloudFormation, Azure Bicep, ARM Template, Azure SDK, and the AWS CDK, Pulumi, and Terra CDK TF, Cloud Deployment Kit for Terraform. So these many provisioning tools available currently in the market, right? But why should we choose Terraform? That we will see now. Okay. First of all, you will see this comparison, right? See this CloudFormation template, ARM template, Google Deployment Manager, and the AWS CDK, and Azure SDK, Azure Bicep. These tools are, we are calling it as cloud native tools. What it means? Using this tool, we can create infrastructure only on its own tool. For example, if you go for AWS CloudFormation tool, using the CFT, you can create infra only on AWS, not to Azure or not to GCP or not to VMware. The same thing for ARM, same thing for Google Deployment Manager. If you go for Google Deployment Manager, you can create infra only on the Google cloud, not on AWS or not on any other product. Okay. But if you go for Terraform or CDKTF or Pulumi, these are the multi-cloud cloud platform. What it means? Using these tools, you can create infra on multiple platforms such as AWS, Azure, GCP, VMware, the other Kubernetes, whatever it is, right? Okay. So from here we will extract these three now. Now out of these three, we will see why Terraform is best tool. Okay. See the comparison. First of all, Terraform is its own language called Ashikoff Configuration Language. Shortly, we will call it as HCL. Okay. And Pulumi, if you go for Pulumi, it is using a TypeScript, Python, Go, .NET. These are the existing software languages. So using that, you have to write the code. Okay. If you go for CDKTF, again, you have to write the code on Python, Java, and all. And if you go for CloudFormation or ARM, you have to write in the JSON or YAML. Same for Google. And if you go for AWS CDK, these two you again you need to write code on the Python, Java, TypeScript, those stuff. And if you go for Bicep, it's again like Terraform. The Azure has created its own language called domain-specific language. So you have to create, you have to write the code on this specific language. Okay. Okay. What is the problem on that? If you see the Terraform, Pulumi, and the CDKTF, as we discussed, these are the multi-cloud platform, right? So these three will be good to choose it because in most of the environment we are having multiple environments, not only Azure or not only AWS. Nowadays, every company is using different tool. So better we can choose either one of these three, right? Okay. Yeah, the cloud integration you already seen it. If you see the coding part, this is very important. If you choose Terraform, it is very easy to write comparatively Pulumi and CDKTF. Why? Because if you write the code on Pulumi or CDKTF, you have to have well knowledge on the programming language such as Python or .NET or C Sharp or TypeScript, those stuff. If you have very good knowledge on the programming skills, then only you can go for Pulumi or CDKTF. Instead of that, if you choose Terraform, it's very easy. It's just a key value pair. It's easily understandable language. You can easily learn it. Okay, that is the main reason we can go for Terraform. Okay, and the debugging stuff, yes, in the Terraform it is easy to debug all the three, and the cloud formation ERM is very moderate, even Google, and these are very good. Bicep is moderate. Okay, community support for Terraform, we have very strong community support. Pulumi is strong, but other things are growing. Okay, and CFT and ARM, it's very strong community support. Google is moderate, just it is upcoming product. And if you go for AWS CDK and Azure CDK, it's also very strong. Bicep is just growing. Okay. Okay. And come to the state file. I will explain you what is state file later stage, but state file is nothing but it is the state of your infrastructure. Okay. For now, just understand that we will discuss in detail on the day specifically. Okay. So Terraform, they are managing stateful locally as well as remotely. The same thing for Pulumi, the same thing for CDKTF. But if you go for other tools, they are managing it internally. Okay, and few of the tools are directly interacting. There is no stateful and all. There is no concept for stateful. Okay. The core reusability. Okay, if you go for Terraform, the core reusability is very much high. Actually, we can easily reuse the code. The same thing for Pulumi and CDKTF. Pulumi and CDKTF is highly reusable even for AWS CDK, Azure SDK, because though we have to write the code on the Python or I mean in the high level language. So as it is high level language, obviously we can easily reuse the code. Okay. But if you go for CFT or ARM or Google Deployment Manager, we can, it's very a moderate code usability. Okay. Okay. ID supports nothing but we have a specific tool to write the code, such as Visual Studio or Atom or Integer, those stuff. If you see, most of all the tools are supporting all the coding language, so there is nothing much to discuss on this. Okay. 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 Now you can understand why we can choose Terraform. Why? Because Terraform is the multi multi-cloud support tool. Using Terraform, we can create infra on a VMware or AWS or GCP or Azure. That is the first point. And second point, it is very open source and it is very easy to write the code. Okay, and no need to write the code in order. Normally, if you take any in any programming language, you need to write the code in specific order so that no, it will execute step by step. But if you go for Terraform, you don't need to write the code in orders. It is very intelligent. It will choose accordingly. Okay, based on the info you're creating. Okay, and having state of resources. So it is always having your no state of infrastructure. So there is no chance to no miss anything. You can easily manage it, manage the existing resource because it is having state. What is current configuration your infra is having, right? Everything is stateful is having, so it is very easy to manage, and it is declarative. What is declarative? Declarative is like you can mention what you need. That's it. No need to go for procedural format. If you go for Ansible, it's a procedural format. You have to tell to Ansible like the step-by-step process. This is how you have to create it. But if you go for Terraform, you just mention what you need. You need to mention the desired uh, infrastructure. Just give an input, just get the output. That's it. Very simple. I will make you understand in the upcoming session how these things will be possible. Okay. Any doubt till now? All good?
Yeah, good. All good.
Yeah, good. Okay. Okay, fine. So, so we have discussed these things, right? What is the problem with the traditional workflow we have here, right? These things. Okay. Using Terraform along with DevOps culture, how we can manage these things very easily, right? That we will discuss now. We have seen what is traditionally how they managed it, and what is infrastructure as a code. We have seen it. Now we will see. Okay, if you see the structure, the same admin one. Previously, he is taking 5 days to create resources on one environment. Okay, but now he is taking 5 days to create Terraform code to create the desired infrastructure. Okay, for example, let's say infrastructure, for example, the number of VMs and the networks or some Azure functions, right, and the networking stuff, those stuff. Okay, the combination of infrastructure for specific project or specific product. Okay, so for that he is taking 5 days to create the uh, Terraform code. Okay, okay, and using that code, he can deploy the resource on all the environment using the same code. You no need to write the code, separate code for all the, different environment. He can write the generic code to create infrastructure because, for example, if you want to create two resources on the dev, the same two resources should be on the QA as well. That's how it should work, right? So he can write the generic code. The generic code can be used to deploy resources on the all the environment by just passing the few inputs. Okay, so how we can do that? He can store the code on the Azure repository. The Azure repository will have that Terraform code, and using the Azure pipeline, he can the Azure pipeline will pull the code from Azure repository and will call the Terraform to create the resources. Okay, that's how we can do it. So using this method, it is a one-time process, right? We can just a one-time work. You no need to write code for each environment, right? And then we can easily reusable because the same code we are using it for all the environment, and it is very quick and fast, very reliable. As we are on the state file, it is easy to audit as well. Okay, so these are we are managing using Terraform with Azure pipeline. These I just explained everything theoretically now, but these things we will from the next session onwards we will see in the practical session as well. I will show you how to write the Terraform code, how to create the pipeline, how to execute it, how to trigger it, everything we will see it. Okay. But we have to go step by step. Okay. Okay. So if you see the 25 days has to be reduced to now 5 days. This is the power of automation. This is the power of DevOps. Okay. 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 Actually, this is the day one. So this is just an introduction class. So these are just we have planned only for 1 or 2 days. But from the day two, it should be 2 hour session. Okay. We are expecting a few more to join now. Okay. Okay. Uh, in the day two, I will explain the most of the people may have doubt on why should we go for Terraform, why we cannot go for Ansible. Anyone is having the doubt? Okay, if you don't have, that's good. Okay, but I will explain you why should we go for Terraform instead of Ansible. Ansible is normally uh, that tool is developed basically to operate the infrastructure. I mean, to automate something on the operation side. It's like a configuration tool, okay? But slowly they have evolved to create the infrastructure as well now. But but even though Terraform is the best tool, I will explain on the next session with some examples with the lab. Okay. Along with that, we are also going to see how to install Terraform, how to configure it, and how to install VS Studio Code to write the Terraform, and how to configure it, and the installation of a few other tools. We will discuss and we'll touch the basics. I mean, we will start the basics of Terraform from the next session onwards. Okay. Any doubt till now? All good?
Yeah.
Okay, fine. Okay. So now let's have some the knowledge check. Okay, so every session, every end of the session, we will have knowledge check so that you will come to know whether really I understood the concept or not. Okay, if you have any doubt, again you can ask. I can explain it again. Okay. Okay. First thing is, what is DevOps in your understanding?
So it's a practice that which in mean combines both the development and operations together.
Exactly. So most of the people may think that DevOps is some tool, but it's not a tool actually. It's a it's a culture, it is a process, it is a practice, that's it. But in the practice we are having so many tools. Okay, so based on our requirement we can choose the tools accordingly, like it may be Jenkins, or it may be Azure pipeline, it may be AWS code commit or code pipeline, right? So there are so many tools available for artifact. We can use Azure artifact or JFrog or Nexus. For testing, we can use Azure Testpen or Selenium. There are so many tools available. Based on requirement, we can choose it. That's it. Okay, fine, super. So what is IAC?
So infrastructure as a code for creating
Yeah,
any
infrastructure as
resources
a
on the
code.
infrastructure.
Yes. So the infrastructure will be in the form of code. That is called infrastructure as a code. That's it. Now, very simple. Okay. So just to list out some IAC tools, whatever you know. What are the IAC tools you know?
Terraform and
If someone
Ansible.
asks you, Uh, Ansible is not exactly the IAC, it is a configuration tool. Okay, I
Pul-
accept Ansible. Any other tool?
Pulumi,
Pulumi?
and then cloud development Terraform kit.
Ah, yes, correct. Okay, so
ARM.
Terraform
Yeah.
and ARM, cloud formation template. See, these are the real IAC tool, not the Ansible actually. Okay, but still we can use Ansible to create the infrastructure, but that is specifically for configuration tool, not the real infra tool. Okay,
I got it.
so actually these are the infra tool actually. Okay, And in Azure DevOps, what are the hosting options we have? You forgot. There are two hosting options we have, right? What is that? Azure DevOps Service and Azure DevOps
Sorry.
Server. Azure DevOps Service, it means using the public portal, we can use Azure DevOps. But if you want to access only within your organization, then you can go for Azure DevOps Server. Okay. Okay, fine. Yeah. So that's it for today. But from day two onwards, it will be very detailed with the practical session. If you have any doubt, you can ask me. Mm, any doubts till now? Any doubts on the course material, course content?
Uh,
Suresh, Suresh, do
like
you have any
these content will be
specific?
uploaded in GitLab, right, Suresh?
Yeah, for every end
GitHub.
of this, everything will be uploaded into this specific repository. This repository link I will
Okay.
share in the WhatsApp. So we will provide access, but right now you will not access, but I will get the email ID from Stanley, and I will provide access to everyone. Okay. So for the day one, if
Sure.
you click the day one, you will see the content. Okay. But for the day
Mhm.
one, you will see only this kind of content. From the day two onwards, you will have the lab sessions actually. Whatever we are discussing on the session, right, along with the coding or practical, those things you can find it on the every folder, every day's folder.
Okay.
Okay. Yeah. But for practicing, you have to have your own Azure cloud or any other cloud. Okay. But preferably Azure cloud is better because we are going to discuss Azure DevOps. So better you have account on the Azure account, and the Terraform I will let you know how to install and how to configure. That is open source. Yeah. Any other thing?
Suresh, do you have any specific exam code for this?
Specific exam dumps or outcome dumps?
Yeah, something like that.
Okay. We have one portal that we are updating. Almost it is having 400 questions, the Terraform questions for writing Terraform exams, right? It's not kind of a dump, but it is having question and answers. But a lot of people know used it and they have passed all the exams. So I think Stanley already shared the link in the description. If not, I will share it.